What if I told you VMware High Availability doesn't actually guarantee high availability? Most VMware administrators assume HA means applications stay online during a host failure. But in reality, HA doesn't prevent outages, it helps recover from them. And that difference is far more important than most people realize. So where does this misunderstanding come from? Ask any business executive what high availability means, and you'll hear the same answer. No downtime, no disruption, no complaints. Unfortunately, that's not how VMware HA actually works. The confusion starts with the name itself. Here's the part most VMware courses never explain clearly. The term high availability creates an expectation of continuous service. But VMware HA is really an automated recovery mechanism. Availability means users can keep working. Recovery means service comes back after an outage. Let's see how this plays out in a real production environment. Imagine it's Monday morning and your busiest ESXi host suddenly crashes. A production host running SQL, application, and web server workloads disappears without warning. Users immediately begin reporting issues. The critical question now becomes, what happens next? Before we answer that, let's clear up some common myths. These 4 myths cause most of the confusion around VMware HA. Many people believe HA means zero downtime, uninterrupted applications, invisible failures, or even fault tolerance. In reality, none of these are guaranteed by VMware HA. To understand why, we need to look inside the architecture. Behind every HA cluster is a lot more intelligence than most admins realize. HA agents continuously monitor cluster health, exchange status information, and coordinate failover decisions. Hosts communicate with one another constantly to detect failures as quickly as possible. And that monitoring starts with something called heartbeats. How does VMware know a host has failed? HA hosts exchange heartbeat messages across the management network. As long as heartbeats are received, everything is considered healthy. When those heartbeats stop, HA begins investigating the situation. But VMware doesn't trust network heartbeats alone. What if the network fails, but the host is still alive? To avoid false alarms, VMware also uses datastore heartbeats. Shared storage provides a second validation method, helping HA determine whether a host is truly dead or simply isolated. Now, let's talk about something that determines whether failover can even succeed. Restarting VMs requires resources, but where do those resources come from? Admission control reserves capacity before a failure occurs. It ensures enough CPU and memory remain available, so workloads can be restarted when a host goes down. Now let's watch what actually happens during a failure. Here's the moment most people realize HA isn't instant. A host crashes, heartbeats stop, failure validation begins. Only after HA confirms the outage does VM restart begin. Notice something important. Downtime has already started, and the internal workflow is even more complex. VMware doesn't simply see a failure and restart VMs. HA follows a structured process. It detects the issue, validates the failure, elects a master host if necessary, and then coordinates VM restarts on healthy hosts. And every one of those steps adds time. Here's the downtime calculation most teams forget. Detection takes time, elections take time, VM booting takes time, applications need even more time to initialize. When added together, these delays create a much larger outage window than expected. And that's where many organizations make another mistake. Just because a VM is powered on doesn't mean users can use it. The operating system starts first. Services load afterward. Databases may perform recovery operations. Dependencies reconnect. Until all of that completes, the application remains unavailable. And this introduces several production risks architects worry about. These are the risks that keep architects awake at night. Long restart windows, resource contention, isolation events, and split-brain scenarios can all affect recovery outcomes. Successful HA design requires planning for these risks before failures occur. Now, let's compare HA with the technology many people confuse it with. So what's the architect's final conclusion? HA recovers workloads after failure through restart. Fault tolerance keeps workloads running continuously using a synchronized secondary copy. One focuses on recovery, the other focuses on continuity. So what's the architect's final conclusion? If you remember only one thing from this video, remember this. VMware HA detects failures and automatically restarts workloads, but it does not prevent outages. HA is a recovery technology, not a zero-downtime technology. Let's summarize everything in one simple lifecycle. The entire HA process can be reduced to 5 stages: detect the failure, validate the failure, elect leadership if required, restart affected virtual machines, recover application services. That's the complete HA lifecycle, from failure to recovery. And here's the question you should ask every time someone says HA guarantees uptime. Before you leave, remember this one question. The next time someone says VMware HA guarantees uptime, ask them, how long does the application take to recover? Because that's the number your users actually care about. Like this video if you learned something new. Subscribe for more VMware architecture deep dives, and comment below with the next VMware topic you'd like explained.